Welcome back to the channel. I am standing in front of my 1986 Mazda B2000, Project LS-2K. The LS should give you a hint of what's going on. But if you haven't seen this before, check out the first video where I kind of go over the what and why of this whole build. Long story short, if you don't want to watch, this is turning into a tube chassis drag and drive car with a twin turbo LS. B2000, LS, LS-2K, got it? Yeah. So this is another episode on that build. However, we're not actually working on the Mazda. We're working on the Mazda project, but not on the car itself. So what are we doing? Well, we are actually going to start working on the chassis jig. Yeah, it's a little bit early, but I have the stuff in, so I kind of want to build it. And we're doing things a little different. So this isn't going to be the standard YouTube home chassis jig, which is, steel I-beam welded together or square steel tube welded together. We're actually using aluminum extrusions. So they're over here. Let me bring you all over here and show you exactly what I'm talking about. Well, this is what I'm talking about. This is aluminum extrusion. This is just coated black because it was cheaper for some reason. You'll frequently hear it, especially in like the 3D printer world, as like 20/20 extrusion or 40/40 extrusion, stuff like that, which is basically just its size. So 20/20 is 20 millimeters by 20 millimeters, and then you have 40 by 40, etc. They do make SAE sizes. The metric sizes do happen to be more usually readily available, and the parts for them are more readily available as well. This is 45/90. So it is 45 millimeters wide by 90 millimeters tall. If you're wondering, that comes out to basically 1 3/4 by 3.5. And this is what we're going to make the chassis jig out of. It'll obviously be turned that way, so at least the bending is in the strong direction. But that is what we are going to be making it out of. So, why are we using this instead of the typical home chassis jig, or table, whatever you want to call it, of steel I-beam welded together or steel tube welded together? Well, there's a few reasons. One of the big ones is weight. Steel tube, once it's all assembled, is actually really heavy. I-beam also really heavy. This stuff is actually really light. So significantly lighter, and because of the size and the shape, it's actually quite strong. So reason number one, since I'm doing a lot of the work by myself, being able to move stuff around by myself is actually a really big deal. The other reason is this stuff is infinitely adjustable. You can put the T-nuts anywhere in these slots and move them however much you want very easily, just by loosening the bolts. When you do steel tube, you've got to use either U-bolts or something like that, or drill a bunch of holes. This keeps me from having to do this, and I can also add additional fixturing really, really easily. It doesn't take very much, and I have some 45/45 extrusion as well for doing a lot of that. Well, one of the biggest reasons I'm using this stuff is for what I can do with it when I'm done. I am hopefully going to finish this project. With a traditional steel chassis jig, or at least of the home-built variety, you are stuck with a giant welded assembly that weighs a lot. So you can cut it apart, but if you ever needed to put it back together for any reason, well, you just cut it apart, and the pieces are now no longer the same length that they used to be. Whereas this, I can take it apart and put it in storage. Think of it kind of like an IKEA flat pack chassis jig. Not quite as quick disassembly and hopefully slightly sturdier than particle board, but that is one of the big things is post-project. I can repurpose this, I can save it. There's a lot of different stuff I can do with it that doesn't involve taking up a ton of room in my shop. Now, the other option is to buy one. They do make them, but they are insanely heavy and quite expensive. So the kind that has all the holes in it, much like a welding fixturing table. They're sweet. Don't get me wrong, and definitely can be better than this. But they're really heavy, really expensive, and then I'm stuck with it until I can sell it. And I would also have to find one for sale. So, again, this makes sense. Now, the one downside to this compared to the traditional steel ones is cost. This is not the cheap way to do it. The steel fixture is the cheapest way to do it because you can just build anything out of like scrap steel. I had to order these. Shipping was actually really expensive. But again, for me at least, the positives outweigh the downside of the cost. It's not that much more expensive, but it is more expensive. So that's kind of the why of what we're doing. Now we're going to start actually laying it out. But what I want to do is go through my design process, my thoughts, and why I'm doing what I'm doing. And hopefully you guys can learn something. I'm not going to go into like all the technical details, but I want to go through at least the thought process of why I'm doing things the way I do. So, with that being said, this is a really long intro, but let's get started, and I'll kind of show you what the plan is. Alright, well, I am standing in front of a whiteboard that I've drawn some stuff on. Might seem like gibberish, we're going to go through it. So the first thing for chassis jigs is we need to know the size. So, lengthwise, we know the length of the Mazda. It's like 14 feet. We also know that we want to be able to have a little bit of room forward and aft to build any fixtures that we might need. So we want to add, say, a foot on either side, 16 feet long. The next thing we need to figure out is the width. We want these two forward-aft running frame rails to sit outside of the Mazda so that we can build any sort of jig straight up to catch anything on the side that we might need. So, width of the Mazda is about 70 inches. So we add a little bit just to make sure 6 feet inside to inside for the cross members. Now, we already talked about for why I'm using this aluminum extrusion is weight, and it has to be something that I can move around. So to do that, we're going to add casters. 6 swiveling casters. One of the big things about building a tube chassis, though, is you have to make sure everything is perfectly level. So, how do we get around that? Well, the easiest way is to use a solution that already exists. That is these guys. These are leveling casters. Got a caster on them, and then these have a ratcheting mechanism that extends this little pad out. So we have, I think, somewhere around ½ an inch of leveling, which is more than enough to make up for any inconsistencies in my concrete. Thankfully, had a really good contractor. The concrete is actually extremely level for the size of building that this is. So we now have a way to move it around. But we want to make sure that it's also super rigid. We know that the extrusion isn't going to bend or do anything crazy, but it is going to flex. And when you're building a tube chassis, you don't want much flex. The size of extrusion that I chose is going to limit that anyways, but one way we can kind of stack the deck in our favor is we can add support in the middle. So 2 more casters, total of 6. We also want to make sure that the frame rails don't bow in and out. So we can add a cross member right across the middle. This also gives us something really good to tie into roughly halfway for building any sort of fixturing that we might need. So now we've got a really rigid frame that we're going to attach casters to somehow. So the nice thing about this aluminum extrusion is it has slots on the bottom or top that run right down the middle all the way the full length. So we have a forward aft running one here and one of our cross members right here. If we mount the casters here, all the weight is on the cross member. We want all the weight running on the forward aft running frame rails. So we'll put it right here. We still tie into the cross member, but we also have more of the load going into the forward afterrunning frame rails. Now we still have this little hole right here that's not supported by anything. So we make a plate. We can use all 4 bolts. That gives a lot even more rigidity to this corner. But, like I said, top and bottom of this extrusion have a slot. Well, the sides do too, except for they have 2. So we can run a plate right here in this corner that'll help us get it nice and square and have it stay square. That runs the full height and can tie into both of those slots. So we end up with a bracket that looks like this. We have a plate on the bottom, and then at a 90-degree angle, we have 2 plates running up with 2 more fastener holes in them that'll help keep that nice and square. The nice thing about this, though, is it works in the corners. You just rotate it. But it can also work just fine in the middle with the cross member. So we're not having to design multiple brackets. All we have to do is design one bracket. We can use it in multiple places. So we can set up jig and fixturing on our welding table and not have to redo it a bunch. The other nice thing about this extrusion is, say, later on, I don't like how little, there should be hardly any flex, but say there's a little more than what I'd like. Since this is infinitely adjustable, even after it's built, I can move that cross member aft and add another one forward. We already know how to make these brackets. We already have the file to cut them out on my plasma table. Casters come in packs of 4, so we know that there are 2 more, so we can add another cross member super easy. That's something that you can't do on a welded steel one. You have to weld the steel in. Well, if your car's sitting on it, you got to figure out a way around this. This, we can slide it in, we can add those fasteners no matter where it is. So that makes this super versatile and, again, a little bit of future-proof for just this project. Well, now that we have a good explanation of what we're doing and why we're doing it the way we are, the next step is to start working on these brackets. So I'm going to get them designed up in CAD and then get that transferred over to my plasma table, and then we'll get them cut out there. after all that cutting on the plasma table and welding and grinding, we end up with this. That looks kind of like that I drew. So this is made out of 3 different pieces, kind of put together with tab and slots like one of the welding tables, and made on a welding table, so it is nice and square, using enough fixturing to make sure that it's square in every direction. So the next thing we want is some sort of a bracket that goes on top of the rails, right about here, on all the corners that we have. And that one. Can't forget that one. So the easiest way to do this would be to make some sort of an L bracket, kind of like that. The downside to this, though, is the layout of the beams. Remember, we've got one that goes this way, and then the other butts up against it. So you'd have 2 fasteners in here and only 1 in here. The easiest way then to get around that, you just extend this. So now you have a true L bracket that's got 2 fasteners in each beam that sits on top and doesn't take up much room or anything like that, but it still adds a lot of strength. We end up with this. So we add this to our existing bracket, and we have this bracket holding the top, we have this bottom plate holding the bottom, and we have this holding the sides, plus this is all welded together. This isn't getting welded together, it's just getting bolted on. Plus, we also have the plate for the caster that bolts onto the bottom of this. What that gives us is a really strong and, more importantly, really stiff joint at every single corner and where our main cross member is. Again, strength-wise, this is way overkill. But we're not necessarily after just being strong enough. We want something super rigid that's not going to have a lot of deflection. And that's why we're probably going slightly overkill. Not probably, we are. Slightly overkill at every one of these joints to make sure we end up with as stiff a chassis jig as possible. Well, now that we have the corner bracket that the casters mount to, and the bracket for the top, we just need 5 more. If only we were this easy in real life. So much welding. Well, now that we have that done, the next step is actually to get started building this thing, which means we got to cut the extrusion using a saw of some kind, and then bolting it together. Well, if you want to know just how accurate the formerly Northern Tool old used off of Facebook Marketplace bandsaw is, put my machine square up there, and it doesn't get much better than that. Or that. Ever so slight gap, but realistically not enough for that I'm even going to worry about. And basically perfect there. So, doesn't get much better. Now that we finally have everything to cut, which the actual cutting took a little over 22 minutes in case you're wondering, for each piece. That's not including lining everything up, that is just cutting. But now that we have that done, we're going to start assembling everything, at least of the main platform. So, that would be the 2 long forward-running frame rails, the 3 cross members, all the brackets and the casters, and then at least that'll give us the basic platform that we're going to use to build our chassis jig. Obviously, for holding the engine and everything else, there's a lot more that's going to go on top of it, but this is the first step, is getting all this stuff set up and ready to go. No, there's not a lot of stuff hanging off of it yet, because the Mazda's not on top of it. So that will be coming, just not now. It actually is really strong and stiff, because remember, that is the priority. Strength-wise, we're fine. Stiffness becomes a priority because we don't want stuff bending and flexing. Some of you might notice that this cross member is a lot closer to the front than it is to the back side of the chassis jig. There's actually a reason for that. If we head back over to the Mazda, I'll explain why. Well, here we are in front of the Mazda. If you're wondering why the front cross member is, the exact measurement is 7 feet from the front of the chassis jig, well, here's why. If we stretch out a tape measure, goes a little bit past, we end up with 72 inches, essentially right here at the door handle. So, we're looking at this car, this layout, what all is in front of 7 feet? Well, the driver is going to be basically sitting right on top of that cross member. So, it's good to have stiffness there, because that's where someone's going to be climbing in and out. Next, we've got the transmission just in front of that. And then just in front of that is the engine. So we have a lot of weight between the back of the cab and the front of the car. Yes, that might be slightly problematic for the whole weight distribution thing, but it's a truck, that's kind of how it is. So it's going to take a little bit of tweaking and figuring to get that better. So back behind the cab, though, we've got the fuel cell, the rear axle, probably catch can and some other stuff, but there's not going to be, as far as the chassis jig is concerned, a lot of weight back there. You also have to remember that that chassis jig is longer than what's necessary, so if we put the front towards the front of the chassis jig, all the extra length is going to be at the back, so it's really not that far off center. It just means that for my application, that is the correct location for it, as far as like supporting all the weight is concerned. Well, this is where I'm going to end the episode. There's not a lot of stuff that goes along with building a chassis jig, so I'm going to call it here. There's still a ton of work that needs done on this project, so there's going to be a lot more episodes. If you're interested in this project, make sure to subscribe so you can follow along, and leave a comment if you are wanting any further information on what exactly it is that I do at any step along the way. I'll be happy to answer as many of them as I can, or in this case, since there's really not very many, all of them. But that's it. Like I said, that's it for this episode. Thanks for watching. Until next time, I'll see you all later.